So we have a couple other types of equations we want to look at solving and practice some of the more complicated ones. And then we're going to get to the main event, which is problem solving with equations. I know when I mention problem solving, a lot of you cringe, but remember, as bad as word problems are, very seldom in life is somebody going to give you, 5 times 2x minus 7 plus 3 equals 4 times 3x plus 1 minus 2x. It just isn't going to happen. That ain't going to work. Plus 2x, we're going to say. It just isn't going to happen. They're going to say, here's the situation, figure it out. And life is a word problem, so we're going to get used to them. By the time we get to the third test at the end of the semester, it's totally word problems, just so you know. So anyway, since I put this one up here, let's solve it. This is about as ugly as they can get. Now remember, here's the equal sign. We always find that first. This one obviously has a lot of simplifying that needs to be done before we can solve it. And it's okay to just look at one side at a time. So we're going to look at just the left side. On the left side, we have parentheses. Anything to do in the parentheses? No. To the parentheses? Yes, times 5. 5 times 2x? 10x. Then 5 times negative 7? Negative 35. Parentheses are done. We still have the plus 3 here. Nothing to combine with the 10x, but negative 35 and positive 3, negative 32. We're done on the left side. Over to the right side. Parentheses. Anything to do in the parentheses? No. To the parentheses? Yes. Times 4. 4 times 3x? 12x. And 4 times 1? 4. Now we still have the positive 2x over here. 12x plus 2x is 14x. And then we still have the plus 4. From here, we can solve. First, what do we have to do first? Get rid of one of the x's. We're going to subtract the 10x to get rid of it. So now negative 32 equals 4x plus 4. And then subtract 4. Negative 32 minus 4. Negative 36 equals 4x. And then divided by 4. Negative 9 equals x. So x equals negative 9. Not so bad? Okay. We can run into ones like this. This is a proportion. We're going to talk about percents a little bit next week. Dealing with percents and proportions, one thing we can do is we can cross multiply. What that means is the cross multiplying means you go at diagonals. And the product you get on those diagonals has to be the same in both directions. So 18 times 27 is, anybody? 486, yes. Going this way, it's a little more difficult. X plus 7 times 54, well, it's 54 times x plus 7. Those two have to be equal. So 54 times x plus 7 has to equal 486. We're going to distribute here. 54 times x is 54x plus 54 times 7 is 378. Then what? Subtract 378. Okay. Will give us 54x equals 108. And then 54. Divide by 54. I don't know where the 4 went and the extra x came from. We'll put it back. So x equals 2. The moral of the story is there are a lot of strategies that can be used to solve equations. the more you do, the easier it's going to be for you to see what strategy to use. So be patient with yourself at first. As you do more of them, you're going to start to recognize patterns, and you're going to start to know which ones, just by looking at them, what you need to do.
In the very beginning, could you change the 18 and 27 to 2 and 3? Or would you not be able to do that?
No, you would not be able to do that, because that would you're not multiplying the fractions; they're equal. If this were times here, then you could cross cancel, but it's not. It's equals. Okay. Well then, on to the main event: word problems. Now, some of them are really almost so simple that writing an equation makes them more difficult. Now, in my math lab, there are going to be some questions where they actually ask you to give the equation or write an expression for something first. And I know that can be frustrating because, like I said, the first couple examples we're going to do here, I would just go ahead and find the answer, not worry about writing the equation. But I'll show you how we go through that with the simple examples. So let's say you plan to save 1/15 of your pay for retirement. If you put away $86, how much were you paid? Although most of us would look at that and say, well, if we're saving 1/15 and we saved 86, you're just going to multiply by 15, right? But let's look at this. You plan to save 1/15 of your pay. So that means 1/15 times your pay, P, equals the $86 that we save. To solve that, what would we do? Times 15 or divide by 1/15. Same thing, right? I would end up multiplying by 15 is simpler. Which is going to give us, what, $9,030? Or no, 900. Help me out there. I screwed that up. 86 times 15 is, yeah, $1,290. So your pay is $1,290 if you saved 86. Now, like I said, those really easy ones are a little tougher, but I want you to get used to seeing equations. Let's say Ted sold $3,381 worth of produce. At $23 each. Make that a little bit larger. How many did he sell? Well, same thing here. There are some of these problems have standard formulas that you use. For example, price times number sold equals your revenue or your total sales. So in this case, the price was 23 times the number sold, we don't know, that's X, equals the total revenue is 3381. So in this case, it isn't so bad to write the equation because there's a standard formula that we can just plug in the amounts to. To solve that, we would divide by 23. So 3381 divided by 23, 147. So we sold 147 units. They do get more complicated. For example, Frank sells 3 times as many t-shirts as sweatshirts. If a total of 128 items is sold, how many of each did he sell? So now there are two things that we're trying to find here. In order to do that, we're going to have to define our variables to make sure we know what's represented by the variable and what's represented by some other expression. So we have t-shirts and sweatshirts. We're representing the number sold. Now I could call one of them X and one of them Y, but we have no clue how to solve an equation with two variables in it. So that would not do us any good. So what we have to do is look in the problem and see, is there one of them, one of those amounts that's referenced off of the other one? And there is in this case. T-shirts are 3 times as many as sweatshirts. What that means is if we knew the sweatshirts, we could find the t-shirts by multiplying by 3. So we're going to define X to be the number of sweatshirts, and t-shirts will be 3 times that, 3 times X. And now we know the total is 128. So if we add up the t-shirts, 3X, plus the sweatshirts, which is X, that better add up to 128 units. So now 3X plus X is 4X equals 128. And we divide by 4. X equals 32. Or we might have, in July, Sherry sold 4 times as many cars as Jim. If Sherry sold 90 more, again, how many did each sell? So again, we have two variables, Sherry and Jim. What we're really looking for is the number sold. Now, is there one of them that's referenced off the other again? Yeah, which one?
Sherry sold 90 more.
Sherry sold 90 more. Yeah, well, that's true, but also there's the 4 times as many. So Jim would be X and Sherry would be 4X. Now the 90 more comes in actually saying the difference between them. Sherry's amount, 4X, minus Jim's amount, which is X, has got to equal 90 because she sold 90 more. So now in this case, it's 4X minus X, which would be 3X equals 90, and divided by 3. X equals 30. Now I stopped here on the last problem. Technically we weren't done yet. What's X represent? Jim. Jim sold 30 units. But to finish the problem, we still need to know how many Sherry sold. Sherry was 4 times X, so 4 times 30, which will be 120. So Sherry sold 120. Up here we should have done the same thing. X is 32, so there's 32 sweatshirts. 3 times 32 would be 96 t-shirts. Of course, you can double check that does add up to 128 units. And here that does subtract to be a difference of 90. Now, that's no fun. Let's do something a little more complicated. We said that we have formulas, standardized formulas. If we're looking at simple interest, which we're going to look at a lot in the 3rd section of the course, in our 3rd unit. Simple interest, the formula is the amount of interest is equal to the principal times the rate times the time. Let's say we are told that in 2 years, so that would be the time, there is $180 in interest at a rate of 3%. So that means I is 180. P is what we're looking for, trying to find the principal. R is the rate. Now the rate is listed as a decimal percent. So instead of 3, it is 0.03. And the time is always listed in years, so 2 years is just fine. Solving an equation like this, we're going to have to do a little bit of simplifying. On the right side over here, we see we can combine the 0.03 and the 2 to get 0.06. So it's P times 0.06. What do we do from there? Divide by 0.06. What does that give us? 3,000 or? Yeah. So $3,000 is our principal. Not so bad? Yes, sir.
You do that to figure out what you'd be paying completely on a house over 30-year mortgage?
That's a little more difficult. We would get into amortization. In the third unit, we'll talk about sinking funds and annuities. And the formula for withdrawing money out of annuity is the same formula for figuring out what your monthly payment would be on a home loan. And then once you get your monthly payment, you can figure out the total cost and the interest amount. We'll go over that in week 13 and 14. Gives you something to look forward to. Outside of regular formulas, we can come into ones that are a little more complex, like let's say t-shirts cost $8 and sweatshirts, yes. Okay, so shirts cost $8 and sweatshirts cost $12. If 4 times as many t-shirts are sold, for a total of $2,200, how many of each are sold? So this one involves going an extra layer into the problem. We still have just t-shirts and sweatshirts that we're looking at here. And we need to define a variable for the number sold. And there's still one of them that's referenced off of the other. 4 times as many t-shirts as sweatshirts. So that means we'll let which one be X? Number of sweatshirts. The t-shirts will be 4X. But the problem is if we add the 4X to the X, we get the total number sold. Are we given the total number sold? No, we're not. We're given the dollar amount. Total dollar amount. So how do we convert the number sold into a dollar amount? Well, how much is it for each t-shirt? $8. So it's $8 times the number sold. What is 8 times 4X? 32X. How much for a t-shirt or for a sweatshirt? 12. So 12 times the number sold. 12 times X is 12X. And so that's the dollar amounts for each. The dollars from t-shirts, 32X, plus the dollars from sweatshirts, 12X, has to add up to the total dollar amount of $2,200. 12 times X. Dollar amounts, yeah, $12 per sweatshirt. That's from up here. So now we're going to solve this. 32X plus 12X is 44X equals 2,200. And then divide by 44. X equals 50. Of course, that's not it. What does X stand for? Number of sweatshirts. There were 50 sweatshirts. But we also need to know
T-shirt.
Number of t-shirts. So that'll be 4 times X, or 4 times 50, which is 200 t-shirts. Questions? Okay. That's one type of example. We've looked at this a few different ways where one item is referenced as a certain number times the other item. But we might have it something like this. Let's say that I'll do this. 7 more t-shirts are sold than sweatshirts. If a total of 49 items are sold, again, how many of each? So again, we're defining t-shirts and sweatshirts. We're trying to define the number sold. But this time they're not defined as one being a certain number times the other. In this case, it's 7 more t-shirts. So it's still, sweatshirts are X, t-shirts are X plus 7, 7 more. So now we know that the total is 49, so X plus 7 plus X equals 49. And what do we do from there? Combine. X and X make 2X plus 7 equals 49. And then minus 7. 2X equals 42. And divided by 2. X equals 21. So 21 is X, the number of sweatshirts. T-shirts is 21 plus 7, or 28. Not so bad? Okay. We'll go up one more notch with this next one. Let's see, t-shirts still cost $8. And sweatshirts still cost $12. But this time, a total of 250 items are sold for a total of $2,200. Once again, how many of each? So how many of each were sold? Once again, t-shirts and sweatshirts. Trying to define the number sold. Is one referenced off the other here? No, there's not. It doesn't say that one is a certain number times the other. It doesn't say that one is a certain number more than the other. It just says total of 250 of them. What that means is one is referenced off the other. It just doesn't tell us which one is which. Truth, it doesn't matter. We can do whichever way we want to. So here we can pick either the number of t-shirts or the number of sweatshirts to be X. Which one do we want to pick? T-shirts. Okay, so if the number of t-shirts is X. How do we represent the number of sweatshirts then? Well, if I were to tell you that 100 t-shirts sold, how many sweatshirts would have to sell? 150. Where'd you get that number? Yeah, 250 minus 100, right? Well, we don't know how many t-shirts sold, but it's the same process. It's 250 minus the number of t-shirts, or 250 minus X is the number of sweatshirts sold. Now, the other piece of information is the total dollars. So we're going to have to deal with the dollars again. And we do that by multiplying the price times the number sold. What's the cost for a t-shirt? $8. So it's 8 times X, or just 8X. What's the cost for a sweatshirt? $12. So 12 times 250 minus X. So those have to add up to, so 8X plus 12 times 250 minus X has to add up to $2,200. Now we have an equation. What do we do to solve it? We see parentheses, which screams that we have to start there. Anything to do in the parentheses? No. How about to the parentheses? Yes. 12 times 250? 3,000. 12 times negative X. Negative 12X. We got to remember there's still an 8X on this side. Anything else we can combine on that side? Yeah, 8X and negative 12X make negative 4X plus 3,000 equals 2,200. Now what? Subtract 3,000. So negative 4X, 2,200 minus 3,000 is a negative 800. This is why we worked with negatives. Bless you. Now what? Divided by negative 4. X equals 200. What was X, though? This is why we wrote this all down. This is why I'm very careful to write this down at the beginning, because otherwise we get to the end of the equation, we know what X is, but what was X, right? X is 200, but what did it represent? There's 200 t-shirts. And the number of sweatshirts is 250 minus 200, or 50. So it's just the same problem as before, just written in a different way. What do y'all think? Gonna make it? Okay. Well, the good news is that's all the new material for the night. Remember, quiz 1 is due Wednesday evening at 11:59 p.m. If at 11:59 p.m. you have one question left, it will still cut you off. Just warning you. If there's something weird, like you get called into work or something tomorrow unexpectedly or whatever, let me know. I'll give you a little extra time if I have to. Then remember, there's also a new homework 2, which is due next Tuesday. Is there anybody that is not in my math lab yet, other than you since you were here? Everybody else? Okay. If you need more time to get into the quiz, let me know. If you don't get the homework all done, it'll be good. Okay. Okay.